Good morning, class. Have you ever found yourself in this situation?
Is also known as the law of inertia. It states that an object at rest will remain at rest until acted upon by an unbalanced force. In this example right here, Chris was stationary, he wasn't moving, the only force acting upon him was the one gravity. Gravity was pulling him down. Andrew with the yoga ball was running he has a certain mass, of course, and he had a certain acceleration. When they collided, Chris had to go back because the gravity wasn't strong enough to hold him against Andrew's force. So when the two collided, the force that Andrew was expressing overpowered the force of gravity that held Chris down.
Next law we're going to be talking about is Newton's second law, which is also known as force is equal to mass times acceleration, or as Mr. Anderson taught us, summation of force is equal to mass times acceleration. So here we got Andrew and Chris from our example earlier. Andrew weighs 70 kilograms and he's running with the acceleration of 3 meters per second squared, and he's going to crash into Chris. To find the total summation of the force, what we have to do is we have to get the mass, which is 70 kilograms, and then we have to multiply it by 3.0 meters per second squared to get the combined total force of 210 newtons. And that's the second law. The second law could be if we're given the force of an object that is like 20 kilograms moving on a frictionless surface. So this object is moving right. So if we want to find the acceleration, we can use the formula. Summation of force is equal to mass times acceleration. And here we know the summation force is 100 newtons. And we know that our mass is 20 kilograms. However, we don't know our acceleration. So to find acceleration, we would divide the mass over and find out that our acceleration is 5 meters per second squared.
Shaky feet, but solid ground. Everyone's on Valium and there's no one around. She can't seem to find a friend in the whole of